Hello, everyone. Thank you for joining us for this AWS webinar, where both AWS and the DevOps Institute will be discussing how and why adopting new tools and data management strategies increases your speed to insights. Today, you'll hear from speaker experts Helen Beal, Chief Ambassador at the DevOps Institute. Helen is a DevOps and Ways of Working coach and an ambassador for the Continuous Delivery Foundation. She's the chair of Value Stream Management Consortium and provides strategic advisory services to DevOps industry leaders. You'll find her across many industry events and speaking opportunities and presentations across the internet and events as they start to roll out. You'll also hear from Kenshin Weicker, a senior solutions architect with AWS. Kenshin supports AWS Marketplace for machine learning team with over 14 years of experience with building, architecting, and managing NLP and software development projects. With a Master's of Science in Computer Science, Kenshin uses her passion for data science to help customers harness the power of machine learning to build more effective AWS architectures. While we won't be answering live Q&A today, you can submit questions for our presenters, Helen and Kenshin, anytime in the QA window. When possible, please include who that question is for. At the end of the webinar, our panelists will review your comments and respond if appropriate. We will also be running a brief survey at the end of the webinar, and we'd love it if you could stay and participate. We have a lot to cover, so without any further delay, I'll go ahead and pass the floor to our first presenter, Helen.
Thanks so much, Erica. It's lovely to be here as always. I am Helen Beal. As Erica said, I am Chief Ambassador at DevOps Institute, amongst other things, and delighted to be talking about data in the context of DevOps today. So the talk map, we're going to start by thinking about outcomes over outputs and think about KPIs and OKRs, and then relate that to data and how we need to ingest and normalize data in order to extract the value. And we'll think about that in the context of DevOps and DataOps and AIOps as well, and then talk about data democracies and providing self-service, and finish by just reflecting what it means to be an insights-driven business and how this relates to customer delight. So let's start by talking about outcomes over outputs. So for a long time, we've measured outputs in business, our kind of things like our productivity. But really what we want to focus on is the outcomes of what we do. So what happens when we commit to the actions and execute the actions? So what are the results of our activities? And we need to think of these particularly in the respect of customer value. So that could be our own business, or it could be the customers that we're serving, external, or of course internal, which is very closely related to business value. Outcomes are much more qualitative than outputs, which are generally very quantitative. So we have much more things around sentiment and feeling and feedback. And really the output is the means to the end, where the outcome is the end. That's the thing that we're trying to achieve. So an example would be, typically businesses are always measuring things like service availability, but actually customers don't care that much. They just want the service to be up. What we might care about more is the volume of customer transactions. That's a real outcome. So just relating to this is something called the watermelon effect. And of course, particularly in traditional waterfall project-driven models, we're very into things like our spreadsheets in particular. So our dashboards and our reports, and these things can often show seas and seas of green. So we think we're doing really well, but we could not have happy customers. Our customers could not be delighted. This is the watermelon effect. The outside looks green, but the inside is red, but we're just not seeing it. So we need to learn to be really much more focused on these outcomes. A couple of minutes on KPIs and OKRs. So key performance indicators versus objectives and key results. Well, actually it's not a versus. A lot of people think it is, but what we should do is use them together. So our key performance indicators tell us how we're doing, whereas our OKRs, or objectives and key results, they're our goals. So they're the things that we measure our outcomes by, and our KPIs tell us how we're doing. OKRs let us set very ambitious goals. So we talk about things like North Star or bags, so big, hairy, audacious goals that help us reach for the stars in order to hit the moon. So they improve alignment within organisations, particularly within management and employee layers. But I think it's really important to note as well that the most effective measurements are driven by the teams themselves. You shouldn't inflict measures upon people. People should be allowed to self-discover them and use them to optimise their own work. And ultimately with OKRs, what we're trying to do is optimise value creation by doing the right things and measuring those outcomes, the value that the customer receives. So let's think about outputs, outcomes, KPIs, and OKRs in the context of data management. So the first example here, we have a KPI. So our indicator is that we are increasing data availability. And the way that we've done that, the action that we took, so our output, was we implemented more connectors. And we had a real outcome for our customers, in this case, the BI team or the business intelligence team, then they were able to process twice as much data. So our OKR that we set was to triple our data sources. So you can see how these connect together. Similarly, we did an action, which was we automated data ingestion. And the outcome of that was that our engineers were able to focus more on innovation and the core projects that they wanted to do, rather than manual, monotonous work around extract, transform, and load, so actually ingesting that data. The KPI, the indicator that was telling us how well we were doing, was how much our data was flowing. So we were seeing our data flow increase. And the OKR that we had set was we wanted to reduce the time that we were spending on ETL. By making a self-service dashboard capability available, we had an outcome where the business teams this time were able to focus on higher level functions. So not doing so much data crunching or asking for data and digging around for data themselves, but being able to self-serve. They were able to release time so they could do more things like data cataloging and enterprise dimensional modeling. The indicator in this particular case were that those business teams had this increasing percentage of time that they were able to spend on innovation and getting those actionable insights. And the OKR was a quantifiable number of dashboards. Another OKR here was about increasing the number of SQL series, or increasing the rate of those SQL queries. So the action we took to achieve that OKR was to replace the legacy database. And the outcome of that was that we had a new platform which allowed us to scale compute and storage much more effectively. And the KPI, the key performance indicator that told us how we were doing, was our infrastructure response time, which we could see improving. And finally, an OKR that was set was we wanted 80% of the organisation to be using our business intelligence dashboards. And the KPI was about being a data-driven organisation, so being able to monitor how many conversations and activities were based on data. The way that this happened, so the output or the action that was executed, was by implementing business intelligence, data pipelines, and dashboarding. And the outcome of that was better business decisions, which resulted in customer delight. So now we've understood how outputs and outcomes and KPIs and OKRs fit inside data management. Let's understand a little bit more about how we get there. So data is very challenging. We've talked about the 3 V's in previous webinars, but if we think about things in particular, volume and variety. So we have a huge amount of data to deal with. It's ever growing in the world and in every business, particularly unstructured data. And we have a huge variety of sources where it's coming from. But before we can really interpret any of that data, we need to normalize it. And that means making it a common language that we can then extract from in order to get our insights that we can then make actionable and then make into outcomes. So we have data coming from places like OLTP databases, applications. We can have third-party sources as well. Web and log data, we have huge amounts of unstructured data coming from social platforms in particular, comments and likes and things like that as well. We have storage buckets and we have CSV and text files. What we need to do is bring all of that into a single place, a data lake, and then make it available in different ways to the people that need to interpret it. So doing things like business intelligence and analytics, being able to use data science, supply it to the business and add tools like AI and DevOps to make it even more valuable to us. So ingestion has changed. So as I said, a huge amount of data, and a huge amount of data is unstructured. And the irony around this, that 80% plus of business's data, is this is actually where there is the most value, whilst it is the most difficult to ingest and normalize. So we've moved from a place where we used to do something called ETL, and we now do ELT. So we used to extract, transform, and load, and now we are extracting, loading, and transforming. This means that we don't need staging with ELT. We can go straight to our target, and it's much better suited for a scalable cloud environment, and much more suited to that all-important unstructured data. It's also much more scalable, as we said, in that it can handle much larger amounts of data, and it's very important for our data lake environments over our data warehouse environments. So it's really good, again, at handling masses of data from masses of different sources, and in particular unstructured data. A small downside, it does require some niche skills, but it is lower maintenance, and because it's SaaS or software as a service, it does mitigate hardware costs as well. So to explain that in a visual way, here you can see on the left our ETL, so we're getting our three sources, we're extracting from them, then we're transforming, and then we're loading it into our target. What you can see on the right is what we're doing is we're extracting and loading, and then we are pushing it straight into our staging tables in our target database, where we are transforming it and making it available to these sources that need to consume it. So just to reiterate, we have huge amounts of data, which is just brilliant. We've got more data than we've ever had before. That's fantastic news. The challenge is there is so much of it. It's so difficult to extract the insights. And insights are good by themselves, but they need to be actionable, and they only become useful when they become outcomes. So let's think for a moment about what we mean by data democratization. This basically means that anybody in an organization has access to the data that they need. It means that there aren't any gatekeepers and there's no bottlenecks. So it's quite different culturally for some organizations. Some people find it quite hard to let go of the gateways to the data and make it available to all. They try and hold it or protect it or govern it. So it does need technology around it to control the ways it's supplied. But what we're ultimately trying to do is expedite decision making so that organizations can find those new opportunities that will help them become higher performing. So the goal is to have anybody use data at any time to make those decisions with no barriers to access or understanding that data. So when we say anybody, of course, there's lots of different personas in our organizations that need different views on data. So the most important personas, of course, are our customer, and they could be external, they could be internals, they could be users of decision support systems or DSS, or they could be our DevOps engineers that are trying to supply new platforms and new ways of interpreting this data. It could be our delivery teams, so our engineering leads, our data analysts or machine learning people, or our data specialists like our data scientists or concierge or engineers. Or they could be our leaders, so our CXO, that's anybody in our C-suite, so our CEO, CIO, CTO, CISO, CMO, anybody with that chief officer in their title, and our engineering managers, of course. And they need different views. So for example, your CXOs might like quite a telescopic view onto the data. They might want to see a roll-up of performance across an organization or across a number of applications. Some people might want to really look at the data much more closely, perhaps under a microscope, really, really close, or under a magnifying glass across other bits. And some might want to really see deep into that data. So we have to be able to supply in the way that each of our personas need the data and in a secure way. Remember, we need to balance people's concerns with governance with people's need for democratization. So remember those KPIs that we were talking about earlier on. KPIs, this is now talking about the dashboard. So this is how to provide that data to people using dashboards. And one thing a dashboard can help us do is actually track our key performance indicators. So lots of people like to track NPS, which is the Net Promoter Score, out of 1 to 10. I'm sure all experienced it as you've used applications on a day-to-day basis, and you've been asked how likely you are to recommend a product or a service to friends or family. NPS is very useful in the consumer environment. It's not always so useful in the business-to-business environment. So we often look at things like referrals and reviews as well in that environment. But other examples are things like the profitability score. So how much after the cost of sales and the cost of retention do you make from that person, or that business? How good are you at converting leads or converting visitors to your website into paying customers? And how big are you in terms of your market share? How much of the business available in your particular market are you getting compared to your competitors? And then net profit. So we can use KPI charts here. And remember, we've got three different types of data. We've got structured, which is our classic RDBMS or relational database. And then we've got our unstructured data, which is text data, and that comes in many forms. I gave the example earlier of social sentiment. So not so much actually the likes and dislikes, but more the comments, so that text data that people are talking about. But we can have lots of other unstructured data like images and documents and contracts and emails. There's huge amounts of this unstructured data. And then we get semi-structured data that's somewhere in between, where we've got a combination of a tabular format and a little bit of unstructured data with it as well. And there's an increasing amount of that. So we need to be able to handle all of these types of data. And a KPI is quite a good example of something that's a little bit of both, because we'll have a bit of numbers in there to track and a bit of textual analysis as well. There are other things that we want to see through a dashboard as well. So there's 4 examples here. We want to see relationships. So typically a way to establish or present what relationships look like is through scatter charts and bubble charts. So scatter charts have 2 variables. For example, you might want to relate marketing spend to sales revenue. So you could have marketing spend on the x-axis and sales revenue on the y-axis, and start looking for a relationship, hopefully a positive one, where the more money you spend on marketing, the more things you sell and your sales revenue increases. In the bubble chart, we're looking at 3 variables. So for example, you could relate your return on investment time and return on investment, your investment time, and your investment size. So you have an X and Y axis again. So here you could have the X axis as investment time and the Y axis as your return on investment, and the size of the bubble would be the investment time, sorry, the investment size. So that would be telling you how well your investments were performing and pinpoint where you might want to make more investments in the future. We also have comparisons. So we have bar charts, tables, column charts, and line charts here. A bar chart's really just looking at one variable. So you could look at, if you were a car manufacturing organization, you could look at the sales of various models of your cars in a given month, for example. With the table, you look at 3 variables. So you could be comparing revenue per employee, revenue growth, and territory size. So 2 of the dimensions would be the row and column of the table, and the 3rd dimension would be the cell value itself. With a column chart, you're looking at 1 or 2 variables changing over time. So things like month over month sales and web traffic. So you'd have 2 columns for each time period, one representing sales, the other representing web traffic. And the x-axis is time in months, while the y-axis is the number, so the amount of sales and the amount of web traffic. And you're looking really for a correlation between those. So probably more web traffic, more sales, and that gives you some insight into your conversion rate. In the line chart, we're really looking at 3 or more variables changing over time and looking at the trends between them. So you could show things like month over month sales, web traffic, webinar registrations, and white paper downloads. With distributions, you've got a column histogram here and a scatter chart. So our column histogram is one variable showing how many customers have made 1 transaction, 2 transactions, 3 transactions. So basically you're counting something and putting them into buckets of measurement, like amount in that particular case, but it could be frequency or duration, for example. The scatter chart's looking at 2 variables. So you could relate return on investments, ROI, and your investment time and investment size, much like we did with the bubble chart. But here we're looking in a slightly different way. We've got the x-axis investment time, y ROI, and again, the size of our bubble here is the investment size. With compositions, we're looking at pie charts, stacked 100% bar chart and a tree map. So our pie chart is really just a very simple share of the total, and you can have multiple things there. So it's the composition of how much, for example, if you're looking at sales, come from each region, or what percentage of marketing leads come from each lead source, or what percentage of responses from a survey are sliced by like gender or some other kind of demographic. Generally, the rule is to try and keep the number of slices in your pie less than 10, otherwise it becomes difficult to read. Your stacked 100% bar chart is the same as above the pie chart, but it's easier to compare multiple sets of stacked 100% bar charts side by side by looking at the relative sizes of a given slice of pie in multiple pie charts next to one another. It's just much easier to compare side by side. And then the tree map shows the composition of your entire customer base, for example, by how much revenue they contribute to the whole. And the benefit of the tree map is that you can display dimensions that have a very long tail versus pie charts and stacked bars, which are best with less than 10 slices. There's other charts as well, like stacked area charts, stacked 100% area chart, column charts, and stacked 100% column charts that are worth thinking about. But there's lots of different ways that you can access these insights and supply them to your different personas through the dashboards. Dashboards are increasingly popular, very popular already and increasingly so, and not everybody has really made full use of them yet. But you must ask yourselves as well, what's the future of dashboards once people have really got into using them? And the future is really about integrating insights into everything that people are doing, so making them available real time within applications themselves, so not having to leave an application to go and find an insight or look for an insight, but actually having it pushed to you as a specific persona in the applications that you live and work in day to day. So there's a number of examples here of different organisations that have managed to do different things. So Canadian Tire, for example, were able to navigate the pandemic by driving insights, AI-driven insights to all their frontline employees real time using the applications that they were using on a day-to-day basis. Nationwide here is reported it's using search and AI to power true data-driven decision-making culture. And I want to talk about data-driven and insight-driven businesses in a bit more detail. So this is some research from Forrester from Enabling Insights-Driven Business coming out in April this year. And some interesting findings that advanced IDB, that's an insight-driven business, were almost 1.5, so 1.4 times as likely as people just beginning to report that they were increasing business innovation, and that was a primary benefit of using their data and analytics. Similarly, they were 1.7 times as likely to say that improving their ability to innovate was their most critical priority. So they had a different set of priorities, the more capable and the more performant they were as businesses. More likely to report more revenue growth, more likely to say that their use of data and analytics has enabled them to drive new revenue streams. So it helps them to diversify their business and put new products and services to market. What does it really mean to be insights driven over data driven? Well, there's a number of examples here. So down the left, we've got the principles, so about strategic investments, about pervasive data, and also being anticipatory, so it's almost predicting what's going to happen and delivered at the edge. We've got that slide from earlier with the rainbow. Remember, we need to go to insights, to actions, to outcomes, and we need continuous experimentation and learning. And this idea of it being a team sport. So if we look at that middle one, data leads to insights, to actions and outcomes. People that are just data aware, so at the lower levels of capability, they're struggling to turn that data into signals and actions. But people that are more data driven are able to create sophisticated visual and predictive signals. So remember that anticipatory from the previous principle, that's predictive signals. But they're still relying on reports and dashboards to suggest actions. In our insights driven business though, we are harnessing these actionable insights from analytics, our employees and our customers, and then we're implementing them all, so integrating them into our business operations and applications to drive action. So let's look at this in the context of DevOps. So in DevOps, we have a subcategory, which is data ops, which is basically applying DevOps principles to our data and analytics world. So we have good practices in DevOps, so things like incremental and continuous change. And if we apply this to the world of data, we know that we need to mine this data really, really fast, and we need to be incredibly adaptable. We don't want people waiting around for hours, days, even weeks for the data that they need in order to make a decision. So we need to design systems from our backlog, so from our idea to the place where we make that data available, that are designed to handle our data in the proper way. Our CI/CD tool chains or our CI/CD pipelines and DevOps tool chains need to be able to handle data. And we need to think of data in the context of the 3 ways as well. So accelerating the flow to the consumer, making sure we receive feedback fast and loudly, so it's shortened feedback loops that are amplified so that we can respond to that and be adaptable. And the third way is that what we just talked about in the previous slide is the continuous learning and experimentation culture. We need to be highly collaborative, so we don't need lots of data silos. If we have data silos, we need to find a way to look at things as a value stream. And we need to have conversations that are data driven. So that value stream centric working means that we don't hand off team to team. We have lovely smooth flow with no waste when we're trying to provide something end to end and drive that by data insights. We have a concept in DevOps that is we build it, we own it. So we need these multifunctional cross-skilled teams. And again, we focus on these value outcomes. So key takeaways, we need business agility. The way to do that is to focus on outcomes over outputs. You must have measures in place, so you must combine KPIs and OKRs. There is more data, we need faster queries, we must have data democratization, and those self-service dashboards are absolutely key to get that data democratization. Having business agility leads to customer delight. So rely on that feedback. Again, use those dashboards to create the actionable insights to allow you to make data-driven decisions that will ultimately give you outcomes. Data ops supercharges your delivery of data, and AI supercharges your data analysis. So you can leverage data to win in your marketplace by harnessing the value and getting those insights, embed those insights where possible and measure purposefully, gain insights across teams and close that loop with experimentation. So you're getting that feedback and pushing it straight through into your next cycle of innovation and learning. So that's it from me today. I'll now hand over to Kanchan. Thank you very much for your time.
Thank you so much, Helen, for such a great presentation. Hey everyone, my name is Kanchan Vaikar, and I'm a Senior Solutions Architect from AWS Marketplace. And I'm going to discuss some tools that can help you modernize your data platform. Let me start with AWS Analytics Stack. AWS provides a whole set of tools and services that you can use to build your data lakes and to run your analytics workload successfully on AWS. Typically, data is everywhere. There is data sitting on an on-prem FTP server or a database or a Hadoop cluster, or even your own data warehouse. And then there is real-time data which is streaming in and constantly getting generated. AWS provides many services to make it easier for you to load your data into your AWS-based data lake. You can use Snowball or Snowmobile to load terabytes and petabytes of data into your data lake. You can also use Database Migration Service to load data from your on-prem database into your database in cloud. And then there are streaming services such as Kinesis, Kafka Managed Service, which can help you address your streaming data requirements. Your data needs to be stored in the right format so it can be easily queried. AWS provides a large selection of different data storage services which help you meet your custom data storage and retrieval needs. Once you have stored the data, you want to analyze the same, and this is where we provide a large selection of tools such as Glue that let you catalog and run ETL jobs on top of your data. And then there is Redshift, which lets you query and combine large structured and semi-structured data sets. There are also other tools such as EMR, which let you run big data processing jobs with technologies such as Apache Spark. And then there is Elasticsearch for your operational analytics needs. There is also Athena that you can use for ad hoc queries, and you can perform real-time data analytics on top of your streaming data via Kinesis Data Analytics. And then there is a service called Lake Formation that lets you govern and manage your data lakes. Amazon QuickSight is a scalable serverless machine learning powered business intelligence service. QuickSight lets you load your data and create interactive BI dashboards. It's important to extract machine learning powered insights to build differentiating features and do more with your data. And that's where AI and ML stack comes into picture. AI ML stack enables AWS customers where they are on their machine learning journey and helps them achieve specific business outcomes. AWS provides the broadest and the largest, most complete set of machine learning and AI services for builders of all levels of expertise. At top layer are AI services, which allow developers to easily add intelligence to any application without needing machine learning skills. The pre-trained machine learning models provide ready-made intelligence for your applications and workflows to help you do things such as personalizing your customer experience, forecasting business metrics, translating conversations, extracting meaning from documents, and a lot more. AWS has a broad spectrum of services to address your business's AI goals. AWS Marketplace also has pre-trained third-party machine learning models that you can use to solve your machine learning problems. At the middle layer is Amazon SageMaker, which provides every developer and data scientist with an ability to build, train, and deploy machine learning models at scale. It removes the complexity from each step of the machine learning workflow, so you can easily build and deploy your machine learning models. The bottom layer is really for the expert practitioners who build machine learning models using the framework of their choice on their AWS cloud. Before we dive deep into products that I'm going to showcase today, I want to recap a few important points that Helen made today. As we are stepping into this modern world, we are pulling together data from a vast majority of sources, and we want to intelligently connect the dots. The data itself resides in different sources and is often dispersed within an organization itself, with two departments not having any visibility into each other's workloads and datasets. The data often needs to be pulled together centrally so you have an ability as well as the visibility into your data. And at the same time, you need governance and control mechanisms to ensure the data privacy wherever applicable. You're also keen on exploring ELT instead of ETL because storage is not expensive anymore. With inexpensive cloud storage, you can easily extract, load, and then transform your data. You need to join the data together and perform analysis using powerful tools while having an ability to easily create dashboards so you're able to monitor the health of your business. And you don't really want to stop there. You also want to train machine learning models and do advanced analytics. So now I'm going to share a story of a customer who had such modern data and analytics requirements. And I'm going to share how they were able to overcome their problems with 3 products from AWS Marketplace. As DocuSign grew over the years, they began to expand beyond the e-signatures into handling every part of the contract's experience. Data analysis and visualizations were fairly decentralized in the company, which led to the data silos and decreased efficiency. DocuSign initially began building a data warehouse to centralize its data processes and to add a BI solution with an intent of tying it all together. Unfortunately, the BI platform they chose proved to be inadequate. The platform couldn't even handle the data they threw at it. It took forever to load the data and it would constantly crash. So DocuSign modernized their data stack with Fivetran, Snowflake, and Click. A typical enterprise has data coming in from a variety of sources, and it becomes important to pull all of this data together in a central place so you're able to join and analyze this data. And this is where ingestion tools such as Fivetran come into picture. With Fivetran, you can pull the data into a central repository so you're able to better analyze it. Apart from data coming in from various locations, there also exists the data that is residing in different silos within an organization and hence cannot be joined together. You really need a solution that lets you work with your data without having to create copies of your data. And this is where Snowflake comes into picture. Snowflake has built an entirely a new way to load, integrate, and analyze data that combines the power of data warehousing while having the flexibility of big data platforms and the elasticity of clouds, and all of this at a fraction of cost compared to the traditional solutions. You also want a tool that is easy, intuitive, and lets you create dynamic data displays in a drag and drop manner without having to code. This is where Qlik comes into picture. Qlik Sense is a new generation data analytics platform that easily lets you create data models in drag and drop manner while giving you an ability to script complex workflows as required. Now let us dive deep into each of these three products. Suppose you want to ingest the data from a third-party SaaS application. Today, you write code that goes ahead, authenticates with the system, downloads the data, and then you have to set up a cron job that goes ahead and pulls the data in on regular intervals. Since this code is going to run often, you need to ensure that it is performance optimized and is idempotent to be able to handle the load failures. And if you need to push this data into another system, you need to re-engineer. In short, you end up building complex data pipeline for each source from which you need to pull the data. And you also need to invest resources in maintaining it, releasing newer versions each time there is a failure due to a schema change or an API change. And this is where Fivetran helps you out. Fivetran is a data ingestion product that lets you outsource these data pipelines to a service that does the task of automating your data pipelines for you. Fivetran automatically ingests and centralizes your data from hundreds of data sources such as Salesforce, Marketo, AdWords, NetSuite, and many others into a ready-to-analyze schema. This enables you to concentrate on analytics rather than having to worry about data ingestion engineering. Fivetran provides fully managed pipelines that are highly available with zero maintenance so that you can focus on analyzing your data, understanding your customers, and improving your product. Let me tell you how it works via a sample use case. Let's say you want to load your Salesforce data into your Snowflake data cloud. Well, you can easily do so. You sign up with Fivetran and then first you choose a source. In this example, it'll be Salesforce, and then you authenticate into it. Fivetran handles scheduling and batching queries, accepting data stores, normalizing it, creating appropriate schemas, tables in your destinations, and finally loading the data into your destination. And all of this happens in a matter of minutes. Fivetran also offers 1-minute level syncs for Snowflake, so your data is continuously getting loaded into your data cloud. It also offers features such as automatic data updates, automatic schema drift handling, which means if column is added or removed, it is kept in sync. It also offers idempotency via micro-batched architecture, which means it is able to recover from data pipeline failures efficiently. Fivetran truly supports your ELT use cases and also goes one step further, letting you do simple transformation on the fly if you need any. Fivetran has over 150 connectors spanning databases and analytics from marketing, sales, product, finance and ops, support, and engineering. All connectors are continuously being tested by Fivetran team, and this continuous testing allows them to foresee issues before they occur. Fivetran also integrates really well with AWS services. Fivetran is able to ingest data from a whole range of AWS database services such as RDS, Aurora, as well as other sources such as S-Stream. It also integrates well with streaming services such as Kinesis. And Fivetran has recently added connectors for CloudTrail, asset inventory, and config to simplify event and data integration. After data ingestion, you load the data into Amazon Redshift or Snowflake. So going back to DocuSign's use cases, after moving to Snowflake, DocuSign really needed a solution to centralize existing and new data sources. They realized that replicating data from source to their data storage required a lot of manpower to build and connect to various sources, often with complicated APIs. And then they required them to maintain those connections. They decided to explore Fivetran, and they were able to connect Fivetran to Snowflake on a 20-minute call. DocuSign has used Fivetran for over 2 years now. And when they decided to use Fivetran, it was the only solution that worked with Snowflake. DocuSign tried a few competitors as they entered the market, but found that Fivetran really still came on top. While the business still uses a few internally built connectors, DocuSign deploys 54 instances of Fivetran connectors. With Fivetran, DocuSign was able to save months of time in terms of engineering cost, while having an ability to increase number of sources they could ingest 3 times. Previously, DocuSign analyzed data from 6 sources. With Fivetran, they can bring data into their Snowflake data cloud from those sources and a dozen more. And this has resulted in a 3 times increase in usable data sources. Snowflake is an AWS advanced technology partner, which provides free trial of its service via AWS Marketplace as well. With Snowflake, you separate out your compute and storage while having an ability to collaborate on same data independently while providing you the pay-as-you-go pricing. With Snowflake, you access a world of data and services by joining a network of thousands of organizations, helping you mobilize your data seamlessly across public clouds as data consumers, data providers, and data service providers. Within the network, you can easily discover and securely share live governed data across your business. Snowflake Data Cloud supports your everyday primary use cases, data engineering, where you build reliable data pipelines using language of your choice, your everyday data warehousing use cases. It also provides you ability to share data with other Snowflake customers via data sharing and building data-driven applications without increasing your operational load. Apart from these, Snowflake seamlessly becomes part of your AWS data lake and supports advanced data science use cases, which I'll talk about in a minute or so. It offers some key features which enable you to perform modern data analytic tasks such as querying semi-structured data, enabling concurrent use cases while offering elasticity with pay-as-you-go pricing. Snowflake lets you store semi-structured data such as JSON, Avro, ORC, Parquet, and XML alongside your relational data, which means you can query all your data with standard ACID compliant SQL and dot notation. You can easily load your data into Snowflake Data Cloud without having to worry about indexing and partitioning. Snowflake does that for you. Snowflake's multi-clustered shared data architecture allows data to be loaded at the same time it is being analyzed. It also supports concurrent use cases with independent virtual compute clusters that reference your common data, thus helping you avoid resource contention issues. So you bring up your own cluster, scale it up or down on the fly, and turn it off when you don't need it. And this really helps you optimize your costs. Snowflake's built for the cloud architecture scales storage separately from the compute, up and down transparently and automatically, so you only have to pay for what you use. Snowflake enables data sharing for you. You can easily forge one-to-one, one-to-many, many-to-many data sharing relationships, so your business units, subsidiaries, and partners can securely query read-only centralized data that is governed by you. With Snowflake, you get an ability to unify, integrate, analyze, and share data at near unlimited scale and concurrency. Due to limited availability of time, I'm just going to double click on data lake and data science workloads today. Snowflake seamlessly integrates with your data lake on AWS. It provides two key mechanisms to connect your data into your Snowflake data cloud. If you do not want to copy the data, you can simply reference your existing data via an external table. And once you have created an external table, you can join the data with other tables from your database and extract further insights. In fact, if you need to do this again and again, you can also consider creating views or materialized views and run high-performance SQL queries. If you want to bring your data over, you can use Snowpipe to do so. Snowflake integrates really well with S3. It lets you do bidirectional transfer, which means you can export or import data from Amazon S3. You might be running your big data workloads on EMR via Apache Spark. Well, you can easily connect your EMR cluster to load data from Snowflake and also write data back into your Snowflake data cloud via connectors. For your streaming data use cases, you either use Kinesis or MSK. Snowflake offers a Kafka connector for MSK that lets you directly load data into your Snowflake data cloud. And you can connect your Kinesis streams to S3 via Kinesis Firehose. And once it's in your S3 bucket, you can either create an external table or load data directly into your Snowflake data cloud. If you're using Glue ETL, you can use the same to push the data into your Snowflake data cloud as well. For visualization, Amazon QuickSight offers native integration to let you directly load data from Snowflake. Third-party data analytics products such as Qlik also integrate well with Snowflake. Most importantly, you can directly integrate your applications with Snowflake and pull the data. Snowflake also enables your data science workflows via integrations with Amazon SageMaker as well as Amazon SageMaker Studio. In your Amazon SageMaker Studio, you can deploy a Python connector that lets you load the data into your notebook instance directly from Snowflake so you can train a machine learning model. If you don't want to load the data into your notebook instance directly, you can store the terabytes of data in S3 and you can pass it to your model training job via the connector itself. For your batch inference use cases, you can also provide large input files you need to provide to the batch transform job via connector. And once the job has executed successfully, you can load the inference results back into Snowflake via Snowpipe. Snowflake also supports your real-time inference use cases. From Snowflake, you can easily perform inference on your SageMaker endpoints via user-defined functions and build dashboards that display real-time predictions. Amazon SageMaker Data Wrangler reduces the time it takes to aggregate and prepare the data for machine learning from weeks to minutes. With Snowflake as a data source for Amazon SageMaker Data Wrangler, you can now quickly and easily connect to Snowflake without writing a single line of code. Additionally, you can now join your data in Snowflake with data stored in Amazon S3 and data queried through Amazon Athena and Redshift to prepare data for your machine learning model training jobs. So going back to our DocuSign case study, as a fast-growing business with a lot of data, DocuSign found that their database was really falling short of their needs. It took forever to load the data and it used to constantly crash. And keeping that in mind, and keeping in mind that this was actually a few years ago when the data volumes were a fraction of what they are right now. The data warehouse was also painfully slow and overnight reloads started at 1 a.m. and they finished by 9 a.m. or later. And this was Pacific time, which means that someone in East Coast office might not get to the data until their noon time. So let me now turn attention to another product. But before I do that, I want to make a very important point, and that is by moving to Snowflake, the DocuSign was really able to see a major change in the performance. By moving to Snowflake, DocuSign saw that the benefit of being able to uh, scale compute and storage was really huge. They also realized that their entire infrastructure is not only scalable, but they also don't have to worry about things such as indexing. And as you can see on the screen, DocuSign is using Snowflake in order to serve a really large portion of their data while getting a really large benefit in terms of the reload time. So let me talk about Click, a software or a product that you can use for your data analytics or BI use cases. Like Helen mentioned, instead of just being data aware, you want to be insights driven, and that's where ClickSense comes into picture. It lets you convert your data into insights so you can build an insight driven culture within your organization. Click offers several consumption models on AWS Marketplace, including enterprise software as a service, enterprise with license, and an option that allows you to bring your own license. With ClickSense, you can create and share dynamic data displays with drag and drop visualizations and layouts without having to code anything. It helps you accelerate your analytics pipelines. You can easily combine and load data and create smart visualizations and drag and drop to build rich analytic applications in a very simple and friendly manner. It provides open APIs and flexible governance to support the scale of large enterprises as well, which means as a large organization, you can share analytics with teams in a one manner. It is powered by artificial intelligence. When you start using ClickSense, you'll see that it provides augmented intelligence, which enhances human intuition via suggested insights, automated processes, and natural language interaction. ClickSense also enables you to integrate advanced machine learning-backed analytics into your dashboards via REST API calls. Let me tell you more. Using Click Analytic Platform, you can easily integrate your SageMaker machine learning model endpoints that solve machine learning problems such as binary classification, time series forecasting, and recommendation engines. Typically, you would deploy your machine learning model behind an API gateway endpoint backed by a Lambda, which would perform the inference on the endpoint. With ClickSense, you can pull the data you want to perform inference on from Amazon S3 and send this data to your REST API endpoint. The Lambda function would accept this data, perform the prediction, and it would return the same in response to the REST API query. And you can augment your analytics by providing these predictions which were returned by the machine learning model. This architecture applies not only to machine learning models you trained yourself in your AWS account, but also to third-party machine learning models you procured from AWS Marketplace. And to enable this real-time inference, you can deploy Click server-side extension, which comes in form of a connector. So via ClickSense node, you would integrate your machine learning models and provide an elastic IP to your node, so your clients are able to render the dashboards via internet. The connector itself is open source and is available to you via ClickPE GitHub repository shown on the screen. Apart from S3 itself, ClickSense also lets you pull your data from various data sources on AWS, such as Redshift, RDS, and also from the third-party data clouds, such as Snowflake. Here is how a typical reference architecture on AWS would look like. Although you can run rim node and central node on a single instance, you would want to separate them out. The central node is the in-memory caching layer where you would load the data, and click rim node is your visualization layer. By separating them out on two different EC2 instances, you would be able to control the data refresh without impacting your customers. And as a best practice, you can leverage multi-AZ for high availability. The setup shown on the screen can support up to 200 users, and to support more, you can always add more new rim nodes. You can optimize this further by auto-scaling your visualization layer up and down based on the number of users you need to support. So going back to the DocuSign case study, before DocuSign started exploring Click, the data analysis and visualizations were fairly decentralized, leading to silos. Employees had no idea about colleagues' works or how the work might actually complement their efforts. They really needed centralized data processes to tie it all together. They knew that they had to get a proper business intelligence solutions. With Snowflake and Click transformations, the whole process, which used to take over hours, now takes 2 to 3 hours. The dashboards with up-to-date data are ready to go when people walk into the door. They initially implemented Click to replace their subpar BI solution, and they continue to depend on Click solution, and they have been doing so for over 4 years now. DocuSign began their data transformation journey with Click by building dashboards within Salesforce. Since transitioning to Snowflake and introducing ClickSense, DocuSign's end users have become self-sufficient. Click loads data in memory, and the users interact with the data through their dashboards. People in various business teams without any technical background build out dashboards that others can easily customize for themselves. They now have over 100 different active dashboards with 80% of the people in the company touching one of the 100 plus Click dashboards in any given month. And most decisions are based on data, not gut feelings. With Fivetron, Snowflake, and Click together, DocuSign's engineers are now able to focus on core projects that aren't just about getting data from a source to a sink. The BI team has moved on to higher level functions such as data cataloging and governance and enterprise data dimensional modeling. The business teams can focus on using the data in Click now. Job responsibilities have shifted and new people have been hired to focus on things they couldn't before, simply because they didn't have the data. And you can find all these three products in AWS Marketplace. AWS Marketplace enables you to find, try, buy, and deploy third-party software. AWS Marketplace contains over 10,000 different machine learning, analytics, data, security, DevOps, and a variety of other products. These are easy to deploy, and a lot of the products are even available as SaaS offerings, so you have nothing to deploy. And the billing of these third-party products is consolidated on your AWS bill. AWS Marketplace also offers a variety of pricing options to fit your specific needs, with many sellers also providing free trials. And if you have a relationship with a seller or a consultant, you can negotiate the price with them and generate a private offer for yourself via AWS Marketplace as well. And if you migrate to AWS and want to bring some of your existing tools, you can use bring your own licensed products as well. There are also multiple deployments to choose from. And apart from the BI tools, you can also find third-party data products in AWS Marketplace, which you can use to augment your analytics and to provide additional insights to your business. AWS Data Exchange makes it easy for you to procure third-party data sets from over 230 different data vendors. AWS Data Exchange contains over 3,400 different data products, supporting a large selection of domains as well as technologies. With AWS Data Exchange, your third-party data bill is consolidated on your AWS bill. And apart from billing, you also get simplified data provisioning with historical and incremental data delivered into your S3 bucket. Once you have loaded the data into your S3 bucket, you can use the tools I discussed to extract insights from this data. And here are some resources that I would definitely recommend exploring to kickstart your data stack modernization process. To summarize, remember that modern data stack is all about helping an organization to transform to insight-driven culture by providing them an ability to pull the data together via tools such as Fivetron. Using tools that let you work with your structured and semi-structured data while ensuring that you are enabling them to concurrently make progress while having an ability to collaborate via tools such as Snowflake. And also about letting your users visualize advanced insights with tools such as Click so they're able to act on it. So I highly recommend you to explore these tools in AWS Marketplace. Try them out, do a POC, and innovate on behalf of your organization. And at this moment, I would really like to thank you for attending our today's session. We truly hope that it was useful. Please feel free to submit questions in the Q&A panel, and we'll get back to you with the answer after the webinar.